Okay, this review is just like the one from yesterday. We could find an interior angle. We could use this formula, 180 times n minus 2 divided by n. We could use this formula for an exterior angle, 360 divided by n. I like this formula. And then to find the interior angle, since an interior angle and an exterior angle always add up to 180, I like to take 180 and subtract the exterior angle to find my interior angle. So a nonagon has 9 sides, so n is 9. 360 divided by 9 is 40. That's my exterior angle. And if I subtract 40 from 180, my interior angle is going to be 140 degrees. A 30agon, n is obviously then 30. So my exterior angle would be equal to 360 divided by 30. So my exterior angle is 12. And my interior angle would be 180 minus 12. Or my interior angle would be 168. N is obviously 16 in a 16agon. So again, my exterior angle is going to be 360 divided by 16. My exterior angle is 22.5. There is nothing wrong with having a decimal. My interior angle would be 180 minus the 22.5. Obviously, if one of them came up with a decimal, the other one is going to as well. 157.5 would be my interior. Pentagon, n is equal to 5. So my exterior, 360 divided by 5, which is 72. My interior, 180 minus 72, which would be 180. Five through 8 work because of this formula. S is equal to 180 times n minus 2. So if I just wanted to solve this for n, I would divide both sides by 180. So I can see I'm going to take the sum divided by 180. And I'm going to add 2 to both sides. So the number of sides, n, is equal to the sum divided by 180 plus 2. So each one of these, I'm going to take 180. I'm going to divide 1080 by 180, and I'm going to add 2 to it. This is 8. 4140 divided by 180 is 23, plus 2 is 25. 6120 divided by 180 is 34, plus 2 is 36. 18,000 divided by 180 is 100, plus 2 is 102. Opposite angles are equal in a parallelogram. So in number 9, I do have one of the equations. It could be written 5y equals 3x plus 10. But I would have both an x and a y. Consecutive angles would add up to 180. So I could do 8x plus 5 plus 5y equals 180. Or I could do 3x plus 10 plus 8x plus 5. Equals 180. And I chose to do this one because it strictly had x's in it. I go ahead and I combine my like terms. I now have 11x plus 15 equals 180. If I subtract the 15, I get 11x is equal to 165. So when I divide by 11, I get x is equal to 15. I could come back here and plug it in, or I could plug it in up here where I wrote out my equation. 5y equals 3 times 15 plus 10. So 5y equals 55, which means y is equal to 11. So x is 15, y is 11. Diagonals of a parallelogram bisect each other. So I have y plus 4 is equal to 3x plus 6. Not what I'd like to start with, because I have both an x and a y. 3y minus 9 is equal to 2y plus 2. So I'm going to solve that one first. If I subtract 2y from both sides, it's going to give me y minus 9 is equal to 2. And if I add 9 to both sides, y is equal to 11. I come back over here and I'm going to plug that in. 11 plus 4 equals 3x plus 6. So I have 15 equals 3x plus 6. Subtracting 6, I get 9 equals 3x. So x is equal to 3. X is 3, y is 11. Number 11, you will have to use a system of equations to find this one, because opposite sides both have a y in it and an x. Y is equal to 3x plus 2. 2y is equal to 4x plus 6. This lends itself well to using substitution. Since I know what y is equal to, where I see y, I can replace it. I'm going to have 2 times 3x plus 2 equals 4x plus 6. Distributing the 2, I'd have 6x plus 4 equals 4x plus 6. Subtracting 4x from both sides, 2x plus 4 equals 6. Subtracting 4, 2x is equal to 2, so x is 1. If I come back up here, I can plug that 1 in. Y is equal to 3 times 1 plus 2, so y is 5. In this case, x is 1, y is 5. Opposite sides are congruent for number 12. So I'd have 2x plus 7 is equal to 5x minus 8. Alternate interior angles are also congruent. So I'd have 3y is equal to 5y minus 50. Solving, subtract 2x from both sides. 7 equals 3x minus 8. Adding 8 to both sides, 15 is equal to 3x. Which means x is equal to 5. If I solve for y, subtract 5y, I get a negative 2y equals a negative 50. Dividing by a negative 2, y is equal to 25. So x is 5, y is 25. Diagonals bisect each other. So 2x is equal to 4. Y minus 1 is equal to 2y minus 7. Dividing by 2, x is 2. Putting my y's together, subtracting y, negative 1 equals y minus 7. Adding 7 to both sides, y is 6. So x is 2, y is 6. In number 14, alternate interior angles are congruent. So 4x minus 1 would be equal to x plus 38. Subtracting x gives me 3x minus 1 equals 38. Adding 1 gives me 3x equals 39. Finally, dividing by 3 gives me x is equal to 13. 15 through 20, any of these should be a gift. 3 or more parallel lines cut by a transversal. If it does it in a way that it cuts the transversal into equal pieces, it cuts every transversal into equal pieces. So on XZ, it cut that segment into 4.8. Every segment between those parallel lines will be 4.8. On MP, it cut NO to 8, so MN will be 8 and OP will be 8. And we simply come over here and we add our pieces together. From M to N is 8. From M to O is 2 of those put together. That's 16. From P all the way to M is 3 of those put together. That would be 24. From O to Z, just one piece, 4.8. From Z all the way to X is 3 of them put together, which would be 14.4. And from Y to Z is 2 of them, which would be 9.6. Number 21 and 22, they didn't tell me anything about this shape, but I can see that it has 4 sides. We mostly all have it figured out, but to figure out the interior angles of a quadrilateral, I'd replace n with 4. We should all know by now that a quadrilateral has 360 degrees in it. So the inside of this one should add up to 360, and I'm just going to combine like terms as I go around. So pay attention as I'm doing it. Y plus 2y is 3y. 3y more makes 6y. 4y makes 10y. All I did was combine my like terms. 18 plus 14 is 32. 32 minus 20 is 12. So if I add all these angles together, they would look like this, 10y plus 12, putting all my like terms together. And this should be equal to 360 degrees. If I subtract 12 from both sides then, I have 10y is equal to 348. And when I divide by 10, I get y equals 34.8. Again, there's nothing wrong with getting a decimal for y. I come over here and I plug that in. So really what I'm taking is 2 times 34.8 plus 18. I found out that this angle was 87.6. And I subtracted that from 180. Since that angle and x makes a linear pair. So x is equal to 92.4. Number 22 is easier. These two angles form a linear pair. So 180 minus 120 is 60. X is 60. The inside still has to add up to 360. So I've used 99, I've used 60, I've used 83, which is a total of 242 degrees out of the 360 that were there. So y is equal to 118. In a kite, the diagonal that's between the two congruent sides will bisect this angle. If this is 42, over here was 42. If this is 3x plus 5, over here would also be 3x plus 5. This pair of angles would be congruent where the 8y is and the 7x plus 3. But if I do that, I have two variables. So instead, I am going to look at this triangle. I know there's 180 degrees in a triangle, so I'm going to add those pieces together. 42 plus 7x plus 3 plus 3x plus 5 equals 180. Combining my like terms, I get 10x plus 50 equals 180. Subtracting 50, 10x is equal to 130, which means x is equal to 13. And I can come over here and plug that in. 8y is equal to 7 times 13 plus the 3. So 8y is equal to 94. And if I divide by 8, y is equal to 11.75. In a kite, the angle that's between the two non-congruent sides would be the same, so x is 130. There are 360 degrees in any quadrilateral. I've used 130, 130, and 86. So I have used up a total of 346 of my 360 degrees. So my remaining angle is 14, which means y is 14. This is also a kite, number 25. This is 51. Over here is 51. This one's 29. Where z is 29. There's one of my angles. Z equals 29. Diagonals are perpendicular in a kite, so I know that I've used 90 and 51. I've used 141 degrees of 180 degrees in a triangle, which means the remaining angle x is 39. And when I go to find angle y, I have the same situation. I've used 90 and 29. I've used 119 degrees out of 180. So the remaining angle is 61. So y is 61. Number 26, base angles of an isosceles triangle are congruent. So 5x plus 26 is equal to 7x plus 10. Subtracting 5x, 26 equals 2x plus 10. Subtracting 10, 16 equals 2x, which means x is equal to 8. AC is a diagonal. BD is a diagonal. This is an isosceles triangle. The diagonals of an isosceles triangle are congruent. So 3x plus 5 equals 4x minus 30. Subtracting 3x, 5 equals x minus 30. Adding 30, 35 is equal to x. Base angles of an isosceles triangle are congruent. So this is 97. The z is also 97. Whatever x is, y is the same. But I do know that same side interior angles add up to equal 180. So if I subtract 97 from 180, I get 83. So x equals 83. Y also would be 83. And z would be 97. It takes two mid-segments to be equal to the sum of the two bases. So I'm going to take 2 times 2x plus 10 and set it equal to 6x minus 12 plus 18. Distributing 4x plus 20 equals 6x plus 6. Subtracting 4x, 20 equals 2x plus 6. Subtracting 6, 4 equals 2x. So x is equal to 7. Here we're just deciding whether it's a rectangle, a rhombus, or a square. It does ask us to explain. This is a rectangle. And the reason it's a rectangle, it has 4 right angles. 31 is a square. It has 4 right angles, as well as 4 congruent sides. 32 is a rhombus. It has 4 congruent sides. 33, because this is a parallelogram, opposite angles would be equal. Consecutive angles add up to 180. So I can see that this is a rectangle, and the reason it's a rectangle is because it has 4 right angles. 34 is a rhombus, and the reason it's a rhombus is it has 4 congruent sides. All of these are rhombuses. Diagonals of a rhombus bisect opposite angles, as well as form 90-degree angles in the center. So, angle 2 in this case will be 90 degrees. This angle and this angle would be the same, 18. Over here would be 18, and this would be 18. I know the measure of angle 2 already. I'm going to list it. I know that angle 1, angle 3, and angle 4 would all be the same. I'm going to find it by taking 90 plus 18 and subtracting that from 180. And I get 72. So angle 1, angle 3, and angle 4 are all 72 degrees. Number 36, angle 4 is the easy one. The measure of angle 4 will be 90 degrees. If this is 71 degrees here, then this would be 71. Angle 2 would be 71. Angle 3 would be 71. So angle 2 is equal to angle 3 is equal to 71. Angle 1 I would find by taking 90 and 71, which is a total of 161 degrees, and subtracting it from 180, which means the remaining angle, angle 1, is 19 degrees. Number 37. Here they didn't draw in both diagonals, but I do know that diagonals bisect opposite angles. So if this is 58, this is 58, 3 is 58, 2 is also 58. So angle 2 is equal to angle 3, both 58 degrees. Angle 1 is going to be equal to angle 4 because they are opposite angles. And if I've used 58 and 58, I've used 116 degrees out of 180 degrees in a triangle. So the remaining angles would be 64. Angle 2 and angle 3 in this case are both 90 degrees. They're both there where the diagonals meet in the middle. Angle 1 and angle 4 would also be equal. If this one's 62, each one of these is also 62. This time they didn't give me any of the ones in the middle. If this is 24, angle 3, angle 4, both 24 degrees. Angle 1 and angle 2 would be equal. Since this is 90, I'd have 90 and 24, 114 degrees that I've used up out of 180. So the remaining angles would be 66 degrees. In problem number 40, where angle 2 is 90 degrees. Since diagonals bisect opposite angles, where angle 4 would be 47 degrees. And again, finding angle 1 and angle 3, they would be the same. I'd have 90 and 47. I've used up 137 degrees out of 180. And I would subtract it to find angle 1 and angle 3, which would both be, in this case, 43 degrees. Because this figure is a square, opposite sides, in fact all four sides would be equal. 5y plus 3 would be equal to 7y minus 5. Solving for y, add 5 to both sides, 2y is equal to 8. Divide by 2, y is equal to 4. They also asked me to find the side length. I do have to plug that back in somewhere. 5 times 4 is 20, plus 3 is 23. So each side would be 23 units long. They've shown me that this is a rhombus. All four sides are equal, so 8x plus 3 is equal to 4x plus 7. Subtracting 4x, 4x plus 3 equals 7. Adding 3, subtracting 3, 4x is equal to 4, which means x is 1. Plug 1 back in. 4 times 1 is 4, plus 7 is 11. Each one of these sides is 11. 2y would be equal to y plus 6. Subtracting y equals 6. If I plug that in, 2 times 6 is 12. So the short side on this rectangle is going to be 12. And if I look at the longer side, I'd have 3x plus 9 equals 8x minus 1. Subtracting 3x, 5x minus 1 equals 9. Adding 1, 10 equals 5x. Dividing by 5x is 2. Plugging that back in, 3 times 2, 6 plus 9 is 15. So the longer side of this rectangle would be 15. Because this is a square, all the sides will be equal to each other. So 4x minus 12 would be equal to 3x plus 4. Subtracting 3x, x minus 12 is equal to 4. Adding 12, x is equal to 16. Plugging 16 back in, 4 times 16 is 64, minus 12 is 52, so the side is equal to 52. If you are in honors class, the two problems that we had in addition to this on the board, the first one should have come out to a square, and the second one should be a parallelogram.